My name's Mark Rymel. I'm Business Development Manager for Socomec, as Daniel mentioned, dedicated to our energy storage solutions. And today's presentation will focus on the benefits of peak shaving for commercial and industrial customers. We have some examples of the return on investment these peak shaving services with energy storage can provide to customers. First of all, a very brief introduction to Socomec. Socomec are an engineering and manufacturing company. We're a French company headquartered just south of Strasbourg, and we're an historic company of 98 years old. We operate across 12 production sites, and our energy storage solutions are manufactured at our European sites in France and Italy, turning over just over 572 million euros. The important thing to note is that we reinvest 10% of this turnover into R&D, and this helps us to provide innovative new products, of which, of course, energy storage has been one over the last few years. To give you an introduction to the background of the company, we manufacture power switching technology, power monitoring devices, power conversion. So for more than 50 years, we've been providing UPS systems. And the reason this is important is that you will find all of these products within an energy storage system. So Socomec were well placed 8 years ago when we made the decision to enter the energy storage market to be able to provide full energy storage solutions using our own products. We have a complete range of energy storage systems to meet the requirements of the market. So from supplying components for AC and DC fuse protection or metering, or simply inverters, to complete indoor systems, fully containerized solutions, which would include all your heating, ventilation, air conditioning, and fire systems, native outdoor solutions, so all of the accessories included within a native outdoor enclosure. And finally, mobile energy storage to target temporary power and to provide a green alternative for temporary power applications. As I mentioned, Socomec have been providing energy storage solutions for 8 years now, and we have more than 180 systems operating around the world. Our largest market has been California in the US, where we have been particularly successful with commercial industrial installations providing peak shaving services. And we're seeing a lot of similarities between the market in California for peak shaving and the markets that are developing in Germany. We also have a large number of sites in Europe, and we also have a number of microgrid installations throughout the world that you can see those yellow dots there. In terms of, just to give you an overview of some of the types of applications that we have installed across those 180 installations, we have energy storage to help with enabling the integration of renewables onto the grid, to support microgrids, as I mentioned, where perhaps you have a weak or no grid connection at all, so using battery storage to support those. We are supporting the deployment of electric vehicle charging infrastructure, so helping to increase the capacity through battery storage and renewables. And we're providing a green alternative to diesel for temporary power applications. Finally, we have also a huge amount of installations that focus on commercial and industrial buildings, and this will be the focus of our presentation this morning. So what are the advantages to customers for installing a battery energy storage system in a commercial or an industrial building? So ultimately, we're looking to help to save money, to decarbonize, and to increase the resilience of our power supplies. So you can see here our battery energy storage system is deployed on the customer side. So it is behind the meter, installed within the customer building. Some of the advantages for this could be to help maximize your self-consumption, so to actually consume your energy on site as opposed to exporting it back to the grid. We can provide backup power services, so in the event of mains failure, to be able to continue to supply the building via our battery storage system. We can participate in grid flexibility services, so to actually help to support the grid. So when there is too much power on the grid, we can absorb it. And when there is insufficient power available, we can inject power onto the grid to help support the grid network. And finally, we can look at peak shaving. And today we are here to look at, we have some examples of the commercial benefits of peak shaving to commercial and industrial customers. So when we have a look at what peak shaving actually means and why it's important, energy companies charge grid fees to help to manage and to help to stabilize the grid network. Our grid fees are based on a consumer's peak demand, so their maximum kilowatts that they consume from the grid. And our target is, if we can reduce this peak demand, we can reduce a customer's grid fees. Ultimately, there are two options possible for doing this. We could look at demand response and load shedding, or on-site battery storage. So here we have an example. If we look at your grid fees will be associated with your peak demand. So regardless of how long you consume that peak, your grid fees will be applied based on that actual peak demand. Therefore, if we can reduce that peak load, we can reduce our grid fees. So the idea of how a battery storage system can help support this with a behind the meter installation is, if we can charge the battery during from the grid during low consumption periods, and then discharge it during high consumption periods to supply this peak in demand. The reason being that these peaks in demand, they're very difficult for our grid companies to manage these peaks, to ensure that there's sufficient energy available on the grid and that our grid network infrastructure can actually cope with these peaks and is big enough to supply them. So they're providing incentives to encourage commercial and industrial users to actually help for them to manage these peaks themselves, and ultimately help the grid companies to manage the grid network. So over the next couple of slides, we have some examples based on what the grid companies are offering in order to help manage these peaks in demand. The first incentive is a scheme called Hårlastsitefönster. My apologies if the pronunciation is not quite correct. The objective is to reduce power demand during peak hours, and these peak hours are defined by the grid operators. The target is commercial and industrial consumers, and we have the calculation here. We will not take too much time, but just to give you an indication of who could be eligible for this type of incentive. You take your highest annual peak demand, subtract your highest peak demand in the time slot that is provided by the grid operator. So for example, could be between 4 and 5 p.m. in the afternoon when the demand on the grid is high. We then divide that by our highest annual peak demand and multiply it by 100. This will give us a percentage, and you can see from the table here as to whether the eligibility criteria. So if we are looking at a low voltage installation, your deviation must be at least 30%. When we look at our highest annual peak minus our highest annual peak demand slot, it must be greater than 100 kilowatts, and the cost reduction must be higher than 500 euros per month. The financing for these incentives is paid through taxes. So everybody contributes to the financing of these incentives through the tax they pay on their energy bills, whether that's a commercial and industrial user or a residential user. Here we have a typical example of a consumer and how a battery storage system can help to provide a return on investment using the Hårlastsitefönster incentive scheme. So here, if we have a typical industrial customer that consumes 2,644 kilowatts per year, during the Hårlastsitefönster period, we are targeting to reduce our consumption by 800 kilowatts. So to reduce this consumption to 1,844 kilowatts. We have a power price of 111 euros per kilowatt. So when we provide our calculations, without the Hårlastsitefönster scheme, our energy bills, our grid fees are 294,000 euros per year. If we then participate in the Horlas site fenster scheme and reduce our peak during this period that is defined by the grid operator, our fees would actually be reduced to €205,000 per year, providing an annual saving of €89,000. So in order to achieve this, we have sized the battery system based on 800 kilowatts. So this would be the difference between our annual peak demand here and our reduced peak demand of 1,844. You can see an 800 kilowatt deviation to last for approximately 1 hour. The budget price for this is €500,000, which ultimately is providing our customers with a return on investment within 5 to 6 years. So you can see here we have the real load profile. So we are charging the battery during the low consumption periods from the grid. Then during this period of Horlas site fenster defined by our grid operator, perhaps between 4 and 5 p.m. in the evening, we are discharging the battery to rectify and to reduce our peak demand in line with our reduced peak during that period, therefore ultimately being able to benefit from a reduction in cost. The second option that is provided as an incentive to help the grid company to manage the grid is the 7,000 hour rule. And the objective is slightly different. We are looking to achieve a flat power demand curve annually. So to be as flat as possible and to avoid those multiple peaks in demand that we often see in a company's profile. The target is energy intensive users, and you can see that you must have a consumption equal to or greater than 10 gigawatt hours per year. And our ratio calculation is also slightly different. So we take our annual consumption in year 1 in kilowatt hours, divided by our highest annual peak demand, and this ratio must be greater than 7,000 hours. You can see if this ratio is greater than 7,000 hours, we benefit from between 80 to 90% reduction in grid costs. An example here, you can see we have a company and organization that has 20,000 megawatt hours annual consumption with an annual peak demand of 20 megawatts. So when we provide the calculation of consumption divided by our peak demand, they are outside of the scope of this ratio at 1,000 hours. And you can see this is the type of profile that the utility companies are keen to avoid and to incentivize companies to move away from because of the complexities of trying to supply this profile. Our second example has the same annual consumption of 20 megawatt hours, but with a highest annual peak demand of just 2.5 megawatts. And you can see this is eligible. The ratio is 8,000 hours. Therefore, this company would benefit from a 90% saving in their grid costs due to having such a flat profile. So on the next page, we will look at how a battery can help to get closer to this flat profile to help to benefit from these savings. So the 7,000 hour rule here, we have a typical example, this time for a data center, whose annual consumption in year 1 was 70,000 megawatt hours, with an annual peak demand in year 1 of 10.4 megawatts. We also have their energy price and power price included, but you can see their ratio is just below the criteria. They are just below 7,000 hours at 6,798, which therefore means they cannot currently benefit from the 7,000 hour rule. On this basis, their current grid costs are €1.7 million. If, however, we could increase that and flatten that profile so that we can achieve a 7,000 hour rule, we could benefit from a saving of €1.4 million based on saving 80% of the grid costs. So in order to reach 7,000 hours, you can see their peak demand must not exceed 10.1 megawatts. That would be their 70,000 megawatt hour consumption divided by 7,000 gives us the 10.1 megawatts. The gap here is 300 kilowatts. We can use and deploy an energy storage solution on the customer site of 300 kilowatts, 2.4 megawatt hours. So a 300 kilowatt system that would last for approximately 8 hours for €950,000. approximately. So you can see on such an installation, the return on investment would be 8 to 9 months through benefiting from an 80% reduction in grid costs would pay for the installation of a battery storage solution. So here you can see the previous profile at 6,798 hours, and using a battery system through intelligent charging and discharging, we have managed to provide a rectified load profile to flatten this curve, which benefits the utility companies, and our client benefits from an 80% reduction in grid fees. How Socomec can help with this? We have a highly scalable and modular solution from 100 kilowatts up to multi-megawatt systems. They're flexible for outdoor or indoor installation, and they are suitable for many different services. So today we have looked at peak shaving, but the batteries could also be used for self-consumption, for backup power, and for grid, and for participating in grid services and receiving payment for grid services. Socomec has a dedicated team of engineering and design engineers to help support your needs, and we'd be very happy to continue the conversation. If you have any questions or would like any further information, we will be available on our booth this morning in the exhibition. Thank you very much for your time, and I hope you find the presentation interesting.